So we're going to factor this by completing the square. The good news is the steps are going to be exactly the same. The bad news is every step is with fractions, so we're going to have to do more work. But if you understand how to complete the square, and if you understand fractions, there is nothing new under the sun here. Half of the linear coefficient is half of 3. If you're not sure at first, half of 3, to get to half, we have to divide by 2. We can interpret both numbers as fractions with a denominator of 1, and then to divide is to multiply by the reciprocal, and that's 3 over 2. Our complete square now is x minus 3 over 2 squared. As long as you knew this, actually, when you're dealing with fractions, you should always have the helper line. So when we FOIL, we get x squared. Then we get minus 3 over 2x minus 3 over 2x. That's minus 3x. And the last piece, what we smuggle in, is going to be 9 over 4. So really, you need here the helper line because there is just too much stuff going on. What we're smuggling in has a denominator 4. What's in the parentheses has a denominator of 2. And then this is an integer, so it's just too much stuff going on. So to this day, I use the helper line when dealing with fractions. I really do have this line. What we're going to smuggle in is 9 over 4. So we smuggled in the 9 over 4. Now the first 3 gets absorbed. X squared minus 3x plus 9 over 4 is the same as x minus 3 over 2 squared. And then we're going to combine fourth and fifth terms. But to combine these two numbers, this is a fraction, so we should think of this as a fraction because we need to bring stuff to the common denominator. So we're going to interpret 10 as 10 divided by 1 or 10 over 1. And now for the common denominator, we have to multiply both numerator and denominator by 4. So then we're subtracting 9 over 4, and we're also subtracting 40 over 4. So you have to be careful whether to add or subtract the absolute values, 9 and 40. In this case, we're subtracting twice, so we're going to have to add the absolute values. And we get minus 49 over 4, which is good news because this is obviously a square because it's 7 squared over 2 squared, or 7 over 2 squared. We can apply the difference of squares theorem between the complete square x minus 3 over 2 squared and 7 over 2 squared. So we get x minus 3 over 2 plus 7 over 2, x minus 3 over 2 minus 7 over 2. Maybe it's a little bit of an algebraic workout, but you will need that much endurance in calculus. Now we're going to combine like terms, so we get x plus 4 over 2, which is x plus 2, times x minus 10 over 2, which is x minus 5. So no one is really surprised at this answer. We were kind of guessing that right from the start. And there is a point we made here. This is an expression where the last thing to deploy is really completing the square. You're not going to need completing the square for an expression as simple as this one. For that, we're going to see, or you already have seen, much better techniques. The reason we're doing this, because by the time we need something like this, things are going to be even worse. So let's just practice it now before we see it in a more difficult situation. Thank you for watching.